Welcome to AS and A-level chemistry. Our topic for today is atomic structure. So this is a topic that all of you are already familiar with because we do this in our middle school, we do this in our IGCSE chemistry classes. So it's a fairly easy topic and we don't have to spend much time on it, but it's still important to revise it once and that's exactly what we are going to do today by going quickly through this topic so that we have our foundations set for the topics that are to come after this, like electrons and atoms and chemical bonding. So let's move further. Elements and atoms. Now, as we all know, an atom is a particle that cannot be divided further by chemical means. So it's a simple single particle, and it cannot be divided by heating or electricity. And we know that it is made up of protons, neutrons, and electrons, which are called subatomic particles. And an element is made up of a particular type of atom. So an element is a species that is that is composed of a specific type of atom. So elements can also not be divided by chemical means because they consist of atoms, and since atoms cannot be divided by chemical means, elements cannot be divided by chemical means. So they cannot be broken down by chemical means. Now every element consists of a different type of atom. For example, the atoms of sodium will be different from the atoms of chlorine, and this is because of the difference in the number of protons, neutrons, and electrons in each of them. So let's move further. Now, we know that the conventional structure of an atom, which was suggested by Niels Bohr, was that we have a nucleus in the center which has protons and neutrons. So I am using a different color for neutrons, protons, and neutrons. And this is quite dense. The nucleus is quite dense because the protons and neutrons are very tightly packed together. And surrounding the nucleus, we have shells. And let's make another one. So we have shells. Let me just make this more circular because it looks a bit distorted. So yeah, this is better. So we have shells, and we know that these shells contain electrons, which are negatively charged particles. So protons are positively charged, neutrons have no charge, and electrons are negatively charged. So let's just use green to make electrons. So we'll have two over here. This is a lithium atom, a typical lithium atom. We have 3 protons, 3 electrons, and we should have 4 neutrons. Lithium has 4 neutrons. So let me just make another neutron over here. So lithium has 4 neutrons, 3 protons, and 3 electrons. So I'll make another over here. Now, we all also know that the filling of these electron shells is by the 2n square rule. So the first shell, which is the first principal quantum shell, is 2 into 1 into 1. N is the shell number. So 2 into 1 into 1 is equal to 2. So we can only have 2 electrons in the first shell. Then in the second shell, we put n as 2, so we can have 8 electrons, and it keeps going like this. So now we also know that in an atom, the number of protons is equal to the number of electrons. So overall, an atom is neutral. It has no charge because, for example, in this atom, we have 4 protons. We have 4 protons, not 4, sorry, we have 3 protons. We have 3 protons in this atom, and we have 3 new electrons in this atom. So we have 3 protons, 3 electrons, so a 3 plus charge because of the protons, a 3 negative charge because of the neutrons. So when we add these together, we get 0. So this means no charge. So an atom is neutral in nature. It has no charge on it. And we also know that the proton number is called the atomic number. So atomic number, for example, hydrogen has 1 proton, so it has an atomic number of 1. Helium has 2 protons, it has an atomic number of 2. Lithium, as you can see over here, has 3 protons, so it has an atomic number of 3, and it keeps going on. Sodium has 11 protons in its nucleus, and it has an atomic number of 11. So as you can see, it keeps going on like this.